Alright, folks, let's go over the warm-up. This is the majority of what you're going to be expected to do on the quiz today. Everybody, you should always be in the habit of resetting your calculator. Go to y equals, put in the function rule. Negative x squared minus 5x and then plus 8. Okay, now on the quiz, I'm going to give you a parabola and then ask you several questions. What is happening? Back. All right. So here's my parabola. First thing I asked you for was a positive root. How do I find a root at all? It's a 0. I put a 0 where? Yeah, on the y equals. This is when the y equals 0. So I must also put in y equals 0. Please don't forget that step or the calculator will forever be asking you for a second curve. And then you do, well, we can look at a picture real quick. I wanted the positive root, which means I want this one. Not this one, but this one. So I'm going to do second function, calculate where they intersect. First curve, second curve, guess. And I'm getting 1.274. Did y'all get that? Yes. Vertex. I saw a lot of kids miss vertex. There are two ways to find vertex. There's a half brain, half calculator way and an all calculator way. The half brain, half calculator is where you find the x value yourself by doing opposite of b over 2a and then find the y that goes with it in the t-chart. So the opposite of b would be positive 5 over 2 times a, which is a negative 1 here. So 2 times negative 1 would be negative 2. As a decimal, that's going to be negative 2.5. So that was my brain part. You can do it as a fraction as well. I figured out the x value. Then I'm going to tell my table to start at 5 divided by negative 2, and it's going to convert it to a decimal for me. And then I look at the table of values. See how it made it into negative 2.5? What's across from it? 14.25. So there's my whole vertex, my x value and my y value. Range. Range is related to the vertex, and this is another mistake I'm seeing a lot on today's quiz. It is related to the y value of the vertex. Range is all about y's. You must know what kind of parabola you're looking at, though. This one is this is opening down. It's a frown. So that means this vertex is the highest point it's ever going to reach. 14.25 is the highest y value I will ever have. All of the other y values, how do they compare to this? They're smaller than it. They're less than it. So the range would be y is less than or equal to 14.25. Some kids are still switching that sign around. Axis of symmetry is also related to the vertex. And yes, I had about 5 kids not put it right, and I counted it wrong. They gave me the right number, but they didn't give me the equation. The axis of symmetry is x equals negative 2.5. It's the vertical line that goes right through the middle of the function. The negative root, let's go back to y equals 0. Now I want this the negative root. So I'm going to do calculate intersection again. But I need to scroll over to the other side because now I want the negative root. Enter, enter, enter. And I'm getting negative 6.274. Okay, now, what in the world am I asking you to do when I say find f of negative 8.3? That's the x. I am giving you an x, and I'm asking you to find the y. I can do that in the table set, or I can do that by calculating a value. Calculate a value. If I hit that, it's going to ask me, okay, well, what's the x value? Well, Ms. Heim told me to use negative 8.3. Hit enter, and pops up the y value. Or I could tell the table to start at negative 8.3, and then look at the table of values, and across from it, there's my y value, negative 19.39. Now, what am I giving you on this last question right here? I'm giving you a y value. F of x means y, so y equals negative 4. I cannot look in the t-chart if I know the y value. I can't control the y's. I can only control the x's. Where do I go to put in y equals negative 4? I go to y equals. Instead of finding the zeros, we're finding the negative 4s. And that's where it draws that horizontal line across the picture. These 2 points have a y value of -4, so we're trying to find the x that made that happen. So then I calculate the intersection, first curve, second curve, guess, and I'm getting 1.772. Okay, and then the other one, I'm going to trace over to the other side. And then do it again, second function, calculate, intersection, first curve, second curve, guess. And the other answer I'm getting is -6.772. Are y'all with me? That's it. Okay, most of the quiz is like that. Any questions on that? Yes. The other questions on one after this, I've pretty much asked you everything I can. Then I'm going to switch to a different function rule, and I might ask you to find vertex of a different function or find range of a different function. No, it is all going to be like this. Now, the other thing I want to point out, domain of any normal parabola, any normal quadratic function. What's domain going to be? All real numbers. So if I ask you for the domain, you're not going to miss that, right? Range is not all real numbers. Range depends on the highest point or the lowest point. Let's say you've got a situation that's a smile. And I'm just making this up. I'm going to just make this up. The vertex is at +3, -2. What would the range of this thing be? Y is greater than or equal to -2. Okay, so finding range is related to knowing the y value of the vertex, and you're either every point above it or every point below it. Domain is always all real numbers. Now, I'm going to go ahead and keep recording through the homework because I want to give you a chance to ask questions. Let's review real quick about this real-life rocket problem. We're doing the quiz at the end. I want to review with you what happens in a real-life problem, folks. Your homework tonight, in fact, is going to be about kicking a soccer ball or a diver diving off a high dive. Or a golf ball going off into the air, or a rocket being launched. Okay, so now let's talk about all the parts of these questions. Normally on these problems, your input is going to be a time value, and your output is going to be a height or distance value. Let's look at all the significant parts of this graph. The y-intercept, which would be right here. The y-intercept is usually where it starts, like the platform that it's sitting on, or the height of the bat when it hits the ball, or how high the diver is on the high dive when he's about to jump in the water. Then the object, the person, the rocket, whatever, goes up, 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 up. It reaches its maximum height at the vertex. Then it starts coming down, 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 down. It hits the water, it hits the ground, whatever it's doing right here. This is where it usually ends. The x-intercept is usually where it ends. Now, a vertex question. They're probably not going to say, hey, give me the vertex of this real-life problem. They're going to say something like this. What is the maximum height the softball reached? What is the maximum height the rocket reached? How high did the diver go? How high did the golf ball go? What kind of question is that? That is a vertex question, but specifically what part? The y. The y would be the maximum height. That's a y number. How would the x number question sound? That would be something about time. For example, how long did it take to reach its maximum height? Do you see what I'm saying? If they ask for a time, they're asking for an x number. If they ask for a height or a distance, they're asking for a y number. Here's the one that kids still get confused on. What are they asking you for there? The x-intercept. How long it's in the air. How long before it lands on the ground. How long did the rocket stay launched? That's this question right here. That's when it ended. The item, the person, the rocket, the ball, whatever it is, it's not in the air anymore right here. And if it's asking you how long, that's a time. How long was it in the air? That's a root problem. That's where it ended. They want the x value and they want the y to be a 0 because it's not in the air anymore if it's on the ground. It's not in the air anymore if you hit the surface of the water. Are you with me? Okay, and then I could ask you other questions. Like I could ask you, what is the height at 7 seconds? What am I giving you here? I'm giving you an x and you got to find the y. Or I could ask you, when does this height equal 100 feet in the air? What am I giving you there? A y, and I'm asking you to find the x. So that's all the things I could ask about a rocket problem. Or a softball problem, or whatever. Now, go ahead and grade your, was this it? Yeah. Grade your rocket problem. Let me tell you that tomorrow is a quiz just like the rocket quiz. So it's going to be exactly like the questions you have in front of you right now, except I'm going to change the equation. All right, questions on this. They're 10 points each. The bonus is 2 points. Go over how long, what now? How long is it in the air? Okay, so this rocket was launched from a 2-foot platform, right? It went up, up, up. It got, I think the vertex was 4,240. What was the vertex? What was the x value? 4,258. So that's when it got to it. That's the time it took to get to its highest height. Then it's coming down, 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 and it eventually lands right here. It's not in the air anymore. This is when it stops being in the air. This is when the height is now a 0. Okay, give me the rocket equation. Y equals what? Oh, whoops. 128x plus 2. Okay, so if I want to know how long it was in the air, in other words, I need to know when it landed. Well, it landed when the height is at a 0. That's an x-intercept question. That's how it would ask you to find the x-intercept. So, do I need to adjust my window here? I do, don't I? Well, actually, I can see where it's landing right here. Okay, so I'm looking for this positive root right here. So I put in y equals 0, and I'm going to see where they intersect. First curve, second curve, guess. Oh, wrong one. I'm on the negative root, aren't I? Alright, let me trace over to the side, which is going to take a while. The negative root really doesn't make sense in this problem because it started on a platform that was 2 feet. Did I go past it? Oh well, let me try it again. Second function, calculate, intersection, first curve, second curve, guess. There it is. It was in the air for 8.015 seconds. You just have to make sure you're on the positive root. The bonus was 2 points. So 10 points for the regular, 2 points for the bonus. Any other questions? Tomorrow's quiz is a rocket quiz. The bonus, okay, the bonus had nothing to do with the rocket problem. The bonus is just knowing about the x and y axis, which I've told you this over and over, guys. You got to know this. The equation of the x-axis is y equals 0. What's the equation of the y-axis? X equals 0. Every x value on the y-axis is 0. Every y value on the x-axis is 0. You gotta just know that. Okay, pass those up. Get out your calculators. Reset them. We're going to learn a new skill today. It's easy, and I think you have done it before. You need to watch the video. We learned a lot yesterday. No. Alright, finding an equation given points. Finding an equation given points. Your calculator can find equations for you if you give it enough information. Okay, lots of times I went through the end of course exam over the last 4 or 5 years, and I pulled out all the questions about quadratic functions, and there were so many of them that were matching equations to points or to t-charts or to a picture, and those are super super easy. You don't want to miss anything where you're matching an equation to a set of points or vice versa. If you're given an equation, you put it into y equals, you look at the t-chart to see if the points are there. Here's what happens if you're given points and you don't know the equation. The calculator can find it for you. One way they like to give points, and this is just such a weird thing to me, they like to use mapping. It's just another kind of version of a t-chart. They might call it x and y, or they might call it x and f of x. What does f of x mean? Y. Okay, -2 is going to be matched to -3. 2 is also matched to -3. Is that a function, by the way? Yes. Okay, it's okay for the y's to repeat. In this example, the -3 is repeating. It's going with this number and this number. It's not okay for the x's to repeat. -1 goes with -3.75, and 0 goes with -4. When they do this to me, I usually like to write out the points to the side, because all those little arrows confuse me. So -2 goes to -3, -1 goes to -3.75, 0 goes to -4, and 2 also goes to -3. So I can tell from looking at the points, the x's aren't repeating. It's a function, as long as the x's don't repeat. Now, in the setup of the problem, lots of times they'll tell you what kind of function is, because sometimes you need to know that. And I am just going to tell you that this mapping represents a quadratic function. Now what they would ask us to do after that is either match that to a picture of the function, or another t-chart with other points that are on the function, or the equation of the function. Okay, so we're going to get the calculator to find the equation for us. Now, this is where I go when I don't know an equation. First of all, let's make sure we got a fresh calculator here. Second plus 712. Now, if I don't know the equation, I can't go to y equals. Y equals is when I know a function rule, or I know what y value I want to use in the function rule. I don't know the function rule. I know a bunch of points. I'm going to go to the stat key. The stat key is right here, kind of in the upper middle, underneath delete. Everybody see it? Stat key. Here's the stat key. You want to push that stat key, and this screen should come up. Are y'all with me? Okay, so again, I hit the stat key and edit. Now, the first thing I want to do is edit. That's when you put in your points. So it's highlighted on edit already. Just hit enter. Please make sure every time you go to enter points that you have L1 and L2. I don't even know what the other columns are used for. We won't use those. We just will use L1 and L2. Some kids accidentally delete the whole entire column, and then you got to reset your calculator. So if you don't see L1 and L2, check that. That's your X column and your Y column, and if they're not there, reset the calculator. Now, I'm going to enter my X values. Please watch what happens here very carefully. I entered -2 and I hit enter. Look where my cursor is. It's on the next X. Okay, so enter these points with me. Nicole, are you entering? -2, and then it's easier usually just to keep entering all of the X values and then go back and enter the Y values that go with it. So I've got -2 goes with -3, -1 goes with -3.75, 0 goes with -4, and 2 goes with -3. Always stop right here and double check yourself. Some kids accidentally leave off an X or a Y number, and it's going to tell you error when you try to get an equation or anything else. Especially that last one, because you got to hit enter. You got to hit the last Y value you put in, and then hit enter. So double check yourself. -2, -3, -1, -3.75, 0, -4, 2, -3. So I'm good to go. I've got all my points. I go right back to stat. It all happens in stat. I already did edit. Guess what we're going to do now? Nope. Now we're going to calculate something, or the calculator is going to calculate something for us. Now, it's not 4. 4 is a line. This is a quadratic function. The one that says quad. So you want to go down to number 5 and hit enter. Then you got to hit enter a bunch of times until it comes up with what A, B, and C are. So what's the equation of this function? No. Y equals 0.25x squared plus 0x, then what? Minus 4. That's the equation that matches these points. I didn't put any x in there because the b value was a 0. It would be okay. You could write it like this also. Y equals 0.25x squared plus 0x minus 4. But usually if it's a 0, they just don't even write it at all. So, okay, well, let's review what we did. We went to stat and edit. We entered the points. We went right back to stat, and we're not editing now. We're calculating, so I had to go to the calculate. Now, if this were a line, I would hit number 4. But it's not a line. It's a quadratic, so I'm going to go down to number 5. And you just got to hit enter and then enter a bunch of times until it tells you what A, B, and C are. Now, how do I know that that's correct? I'm going to go to y equals now and put in 0.25x squared minus 4, and I'm going to look at my t-chart. Those points that I was given better be there. Look, there's -2, -3, there's -1, -3.75, 0, -4, 2, -3. That is correct. So if they gave me these points and they wanted to know the picture or the equation, I could look at the picture and I could match it to the right picture. I could look at the equation and match it to the right equation. I could even look at other points. I could find other points that are also on that function by looking at the t-chart. So matching equations to functions, you don't want to miss any of those. The calculator can do it for you. All right, now, Christopher, sit up. It took you 4 days to catch up with what we have been learning, and now we're learning something new. Now this, you can also graph points. I want to show you what you can do if you don't know if it's quadratic or not, okay? Sometimes they give you a set of points, and they don't tell you what kind of function it is. I told you this was quadratic. What you can do is edit, put in the points, but let's pretend for a second that we didn't know that this was quadratic. We didn't know what kind of shape the points were going to be in. Okay, this is what you can do. Go to y equals. Please clear out the equation. I don't want the equation in there. I want to show you how it can graph points for us. The way it graphs points is if you go up to plot 1, hit the arrow key up to plot 1, you better catch up. And hit enter until it's highlighted. Normally, you don't want that highlighted. Well, highlight it, hit enter, and then come back down. It shouldn't be blinking. Then hit graph, and it's going to graph those points. And you see how it's not lining up in a straight line, it's lining up in a curve. That's the bottom of the curve. Now, I'm going to go back and put the equation back in. 0.25x squared minus 4. And look, it's going to graph the function through those points. Okay, so this was a parabola. It was quadratic. Okay, you messed up your window somehow.
Wait, I didn't even touch it.
Well, you did, obviously.
And then what do I do next?
Okay, then I just went back and put in the equation, and I graphed the equation and the points together, and I saw the parabola went through those points. Okay, if you wanted to graph points for you, if you want to see the points that you entered in the stat edit screen, if you want to see the points actually plotted, because they don't always tell you what kind of function it is. So sometimes you want to see if the points are lining up in a straight line or if they're lining up in a curve. So if you want to see the points that you have already entered in stat edit, then you go to y equals and you hit the arrow up and you want to highlight where it says plot 1. Okay, and then I just unhighlighted it. It should be highlighted in black. And then when you hit graph, it's going to graph the points. Mine's also graphing the equation because I went back in and put in the equation as well. All right, clear that out. Reset your calculator. Oh, wait. Sorry. Go back to stat, please. I want to show you something. This is important because kids, everybody, please stay with me. Kids do this all the time and they don't even know that they've done it. If I want to clear out old stuff so I can put in new stuff, there's 2 ways to do it. The delete and the clear key. However, please listen. Delete works when you're highlighted over the actual X or Y value and it deletes one at a time. Clear works if I highlight the title of the whole column and I hit clear and then enter, then it clears them all out at once. Here's what you don't want to do. If I highlight the title, this is my X's right here. My L1 is my X's. If I hit delete, look what happens. What did it do? It deleted the whole X column on me. If I hit delete when I'm highlighted up there, it deletes the whole thing. How do I get it back? You got to reset the calculator. Okay, so anytime you start with stat edit, you got to make sure your X and Y are there, your L1 and your L2. All right, I'm going to give you another problem. And this one has more points. Go to stat and enter those points. Go to y equals and take out the equation. Let's go to stat and let's enter all of those points. Yes, it's a lot of them. Okay, you want me to shut up in other words? All right, I'm going to stop talking. Do it by yourself. I'm going to do it while you do it. My voice doesn't help you concentrate. Oopsie. Ooh, I messed up, didn't I? Yikes. See, look what I just did. Negative 4, 5.25. Negative 3, 6. Negative 2, 6.25. Oh, wait, I left out negative 1, 6. And then 0, 5.25. And then 1, 4. There's 2 6s on the points. Okay, what I want to do first is I want to see if this is quadratic. Spoiler alert, it is. I'm going to go to y equals and hit plot, highlight that plot, and then hit graph, and it's going to graph the points for me. And it does look like it's making a parabola. It's not the whole parabola, it's just part of it. What else can I get the calculator to tell me? The equation. Okay, so to get the equation, though, I've got to go right back to stat. I already did stat edit, but now I want to calculate. And we know it's quadratic. We looked at a picture of it. And then hit enter a whole bunch of times. And there's my equation. Y equals negative 0.25x squared. Isn't it negative? Negative 0.25x squared minus 1x plus 5.25. I'm running out of space here. Plus 5.25. Please go to y equals and let's enter that. Plus 5.25. Y equals negative 0.25 x squared minus x plus 5.25. And now when I graph it, it should go right through those points. Plus 5.25. Remember, go to stat, calculate. We were looking at the quadratic regression and hit enter a bunch of times and it tells you what A, B, and C are right there. And then write those down somewhere and then enter it. And sure enough, look at that. Now, we did all that work, but let me tell you a sad but true story, okay? 2 years ago, when this was actually on the end of course exam, and I was walking around the class that I was testing, and I saw kids looking at this question and just almost tears in their eyes, because it said, the way they wrote it sounded so complicated. It said this, if 3 comma 0 is a solution to this function, if 3 comma 0 is a solution to the function, where else does f of x equal 0? Yes. Yeah, it's right here. In other words, the 3, it was just they were telling you, hey, guess what? Look at the picture of this thing. They were just telling you 3 comma 0 is one of the roots. Is it in the table of values? No. It's one of the roots, though. I can see from my picture. 3 comma 0 is the solution to this function. Where else does this function equal 0? Right here. So it wasn't even a problem they had to do any math for. It was just looking at the t-chart. Guess what some kids picked? This one. Is that a 0 of the function? That's a y-intercept. That's not an x-intercept. That's not a 0 of the function. That's a y-intercept. This is a 0 of the function. This is where f of x or y equals 0. And the other place it equaled 0, just a random fact they told us, was 3, 0. We didn't even need to know that. Okay, anyways, that's your lesson. If I give you points, you should be able to give me the equation. All right, get out a piece of paper for your quiz. Your homework is a worksheet. I'm going to give that to you in a minute.